As we age, one of the earliest and most overlooked signs of declining health isn't our memory, vision, or even our heart, it's our legs. Muscle loss, weakness, and instability often start in the lower body, sometimes decades before we notice serious problems. Science calls this sarcopenia, and it begins as early as our 40s, accelerating rapidly after 60. The consequences can be life-changing: reduced mobility, loss of independence, and increased risk of falls and fractures. But here's the good news. Cutting-edge research in longevity and metabolic health shows that the right foods, rich in specific nutrients that combat inflammation, enhance mitochondrial energy production, and support muscle protein synthesis, can dramatically slow and even reverse this process. Today we're diving deep into the 6 scientifically proven foods that can help you rebuild strength, maintain balance, and protect your legs from the silent creep of muscle decline. This isn't about fad diets or quick fixes, it's about real science and the choices that can keep you moving confidently for decades. As we grow older, something subtle but incredibly important starts happening inside our bodies, often long before we notice the first visible signs. Our legs, which carry us through life, begin to lose their strength faster than nearly any other part of our body. This process doesn't happen overnight. It starts silently in our 30s or 40s and accelerates rapidly after 60. Researchers call it sarcopenia, and it's one of the most powerful predictors of aging-related decline. Weak legs don't just mean difficulty climbing stairs or getting out of a chair. They signal deeper problems: loss of muscle mass, reduced metabolism, insulin resistance, and even higher risk of falls, fractures, and long-term disability. But why do the legs weaken first? To understand this, we need to explore both biology and lifestyle. Our leg muscles are among the largest in the body, responsible for movement, balance, and stability. They demand constant energy and strong nerve muscle communication to function properly. As we age, 3 interconnected factors begin to chip away at this system: reduced physical activity, declining muscle protein synthesis, and age-related hormonal changes. Let's start with physical activity. Modern life has engineered movement out of our daily routines. We sit for hours relying on cars and screens while our ancestors spent their days walking, climbing, and lifting. When we stop challenging our muscles, especially the big ones in our legs, they begin to shrink through a process called disuse atrophy. Muscles are incredibly adaptive. Give them resistance, and they grow stronger. Neglect them, and the body conserves energy by breaking them down. The legs, carrying most of our body weight, are the first to show this decline because they are used less vigorously as we age. Walking slowly to the kitchen or strolling around the house isn't enough to trigger the signals for growth and strength maintenance. Without deliberate activity like resistance training or regular brisk walking, the powerful quadriceps, hamstrings, and calf muscles gradually weaken, leading to instability and fatigue. But inactivity is only part of the story. Inside our cells, a deeper biological process unfolds. Muscle growth and repair depend on muscle protein synthesis, the ability of our bodies to rebuild and maintain muscle fibers after they break down from daily wear and tear. When we're young, this process runs at full speed. We eat protein, exercise, and the body efficiently converts nutrients into strong, healthy muscle tissue. But after our 30s, and especially after 60, the efficiency of this system plummets. Scientists call this anabolic resistance. Even when older adults eat enough protein, their muscles don't respond as robustly as younger ones do. This means the same meal that helps a 25-year-old build muscle may barely maintain it in someone twice that age. The legs, with their massive muscle fibers, are hit hardest because they require more protein synthesis to stay strong compared to smaller muscle groups like those in the arms or shoulders. Hormones also play a crucial role. Testosterone, growth hormone, and insulin like growth factor 1, IGF-1, all essential for muscle growth, decline steadily with age. These hormonal shifts reduce the body's ability to build and preserve lean muscle mass. Meanwhile, chronic low-grade inflammation, sometimes called inflammaging, creeps in, further accelerating muscle breakdown. Inflammatory molecules like cytokines interfere with muscle repair signals, creating a vicious cycle. Weaker muscles lead to less activity, which leads to more inflammation, which then causes even more muscle loss. Again, the legs, carrying the most muscle mass, suffer the most from this biological tug-of-war. Another hidden factor is Mitochondrial decline. Mitochondria, the tiny energy factories inside our cells, power every contraction our muscles make. With age, mitochondria become damaged and less efficient, producing less energy and more harmful free radicals. Leg muscles, requiring constant bursts of energy for walking, climbing, and balance, are particularly sensitive to this energy deficit. When mitochondria falter, so does our ability to stay active and strong. Nerve health also plays a role. Our muscles rely on motor neurons, specialized nerves that tell them when and how to contract. Aging causes a slow but steady loss of these motor neurons, especially those connected to fast-twitch muscle fibers responsible for strength and quick movements. The result? We lose power and speed in our legs, making falls and injuries more likely. What's fascinating is how early all this begins. Studies using imaging techniques like MRI show that even healthy adults in their 40s start experiencing measurable declines in leg muscle mass and strength. By the time we notice difficulty standing up from a chair or climbing stairs, significant damage has already been done. Researchers now believe that early intervention through diet, exercise, and lifestyle changes can delay or even reverse much of this decline. It's also worth noting that leg weakness doesn't just affect mobility, it sets off a cascade of health problems. Weaker muscles burn fewer calories, contributing to weight gain and metabolic disorders like type 2 diabetes. Reduced activity leads to poorer cardiovascular health, stiffer joints and bone loss, since strong muscles are needed to keep bones dense and resilient. Even brain health suffers because physical activity, especially walking and strength training, boosts blood flow and releases chemicals that protect neurons from aging. In the field of longevity research, scientists like myself see leg strength as a critical marker of biological age. Two people might share the same chronological age of 70, but the one with stronger legs, better balance, and greater muscle mass is often biologically much younger. In fact, studies show that leg strength predicts not just mobility but overall survival, better than many traditional health measures. The good news? This decline isn't inevitable. We now know that with the right combination of nutrition, targeted exercise, and lifestyle strategies, we can slow, stop, and even reverse much of this age-related muscle loss. The legs may weaken first, but they can also respond first when given the proper tools for repair and growth. And this is where diet becomes central. Certain foods provide the raw materials and signaling molecules our muscles need to thrive. They help fight inflammation, boost mitochondrial function, support protein synthesis, and stabilize the hormones that protect muscle tissue. When combined with regular movement, especially resistance training, they create a powerful defense against the leg-weakening effects of aging. In the coming sections, we'll explore exactly which foods deliver these benefits and how to incorporate them into your daily routine for stronger, healthier legs fast. Because longevity isn't just about living longer, it's about moving through life with strength, energy, and independence. The connection between what we eat and how strong our muscles remain as we age is far deeper than most people realize. It's not just about calories or protein or hitting some arbitrary daily nutrient target. It's about feeding the intricate biology inside our cells, supporting the molecular machinery that keeps muscles healthy, strong, and resilient. For decades, the focus was on exercise alone. People assumed that if you just lifted weights or walked enough, you could maintain strength indefinitely. But research over the past 20 years has revealed a much more complex story. Nutrition doesn't simply fuel our muscles. It instructs them. Food delivers molecular signals that can either switch on repair and growth or accelerate weakness and decline. Let's start with the fundamental process of muscle health, muscle protein synthesis. Our muscles are in a constant cycle of breaking down old, damaged proteins and building new ones. When we're young, this system is incredibly efficient. A simple workout and a meal rich in quality protein can rapidly trigger growth and repair. But as we age, something changes at the cellular level. The same signals that used to stimulate robust muscle repair become weaker, a phenomenon scientists call anabolic resistance. This means older adults need a stronger signal from both exercise and nutrition to achieve the same muscle-building effect as someone in their 20s or 30s. Here's where nutrition becomes critical. Certain nutrients act like molecular keys that unlock muscle-building pathways in the body. One of the most studied is the amino acid leucine, found abundantly in foods like eggs, lean meats, soy, and legumes. Leucine activates a pathway called mTOR, which is essentially the master switch for muscle growth. In younger individuals, even small amounts of leucine-rich food can flip this switch easily. In older adults, however, you need both a higher protein intake and specific timing to fully activate the pathway and overcome anabolic resistance. But it's not only about protein. Muscle strength depends heavily on the health of our mitochondria, the tiny power plants inside our cells that generate energy in the form of ATP. When mitochondria function well, our muscles contract efficiently, resist fatigue, and recover quickly. With age, mitochondria decline in both number and efficiency, producing less energy and more free radicals that damage muscle fibers. Here's where certain nutrients come in. Omega-3 fatty acids, found in fatty fish like salmon or in plant sources like flax seeds, have been shown to improve mitochondrial function and reduce inflammation in muscle tissue. Polyphenols from foods like blueberries, green tea, and olive oil also protect mitochondria by activating longevity genes such as sirtuins, which repair cellular damage and boost energy production. Inflammation is another major player in muscle health. Chronic low-grade inflammation, sometimes called inflammaging, creates an environment where muscle breakdown outpaces repair. Pro-inflammatory molecules interfere with the anabolic signals that normally tell muscles to grow stronger. Diets high in refined sugars, processed foods, and unhealthy fats fuel this inflammation, accelerating muscle loss. On the other hand, foods rich in antioxidants and anti-inflammatory compounds, think colorful vegetables, berries, nuts, and spices like turmeric, can dampen this inflammatory storm, creating a more favorable environment for muscle preservation. Vitamin D deserves special mention here. Known for its role in bone health, vitamin D also directly influences muscle strength. It binds to receptors in muscle tissue, improving protein synthesis and neuromuscular function. Deficiency in vitamin D, which is surprisingly common in older adults, is strongly linked to muscle weakness, falls, and frailty. Ensuring adequate vitamin D through sunlight, diet, or supplementation can dramatically improve leg strength and stability. Then there's the gut-muscle connection, a fascinating area of emerging research. The microbes living in our intestines produce metabolites like short-chain fatty acids that influence everything from inflammation to energy metabolism. A healthy gut microbiome, fed by fiber-rich foods like legumes, vegetables, and whole grains, may actually enhance muscle strength by reducing inflammation and improving nutrient absorption. On the flip side, a poor diet lacking in fiber and rich in processed foods disrupts the gut microbiome, increasing inflammatory compounds that contribute to muscle loss. Another often overlooked factor is insulin sensitivity. Muscle is the primary site where our bodies store glucose after a meal, under the direction of the hormone insulin. As we age, many people develop insulin resistance, meaning their muscles no longer respond properly to insulin's signal. This not only increases the risk of type 2 diabetes, but also reduces the muscle's ability to take up and store nutrients efficiently, impairing growth and repair. Diets rich in whole, unprocessed foods with plenty of fiber and healthy fats can improve insulin sensitivity, ensuring muscles get the fuel they need without the damaging spikes in blood sugar that come from processed carbohydrates and sugary foods. And finally, hydration. Something deceptively simple plays a bigger role than most realize. Muscle tissue is about 75% water, and even mild dehydration impairs strength, endurance, and recovery. Older adults often have a reduced sense of thirst, leading to chronic low-level dehydration that makes muscles more prone to fatigue and injury. Nutrient-rich fluids like water infused with electrolytes, or even water-heavy foods like cucumbers, oranges, and melons help maintain the cellular environment muscles need to function optimally. When you put all this together, a clear picture emerges. The foods we eat directly influence the molecular and cellular pathways that control muscle health. Protein provides the building blocks. Omega-3 and polyphenols protect mitochondria and reduce inflammation. Vitamin D strengthens neuromuscular signaling. Fiber supports the gut microbiome. And balanced whole food diets maintain insulin sensitivity and hydration. It's not about one magic nutrient or superfood. It's about creating a nutritional environment where muscle preservation becomes the default rather than the exception. Exercise sends the initial signal for growth, but nutrition determines whether that signal translates into real strength gains or fades away. In older adults, where every small advantage matters, aligning diet with these molecular needs can mean the difference between frailty and independence in the later decades of life. This is why when we talk about foods to strengthen your legs fast, we're not just thinking about calories or protein grams. We're thinking about how to nourish the entire ecosystem inside your muscles, from mitochondria to hormones to the microbiome, so that they can keep you moving powerfully and gracefully through the years ahead. When it comes to preserving strength and mobility as we age, science is increasingly clear. The foods we choose can either accelerate muscle decline or provide the raw materials and molecular signals that keep our legs strong for decades. We've already explored why the legs weaken first and how nutrition influences muscle health on a cellular level. Now let's focus on 6 specific foods that researchers consistently highlight for their ability to support muscle growth, protect mitochondrial function, reduce inflammation, and ultimately help us maintain strength and independence as we age. These aren't exotic, hard-to-find superfoods. They're practical, evidence-based choices that deliver measurable benefits when integrated into daily life. The first is salmon, or other fatty fish like mackerel and sardines. What makes salmon remarkable is its rich content of omega-3 fatty acids, specifically EPA and DHA. These compounds do far more than protect the heart. Studies show they improve mitochondrial function inside muscle cells, reducing the oxidative stress that damages muscle fibers as we age. Omega-3 cells also enhance muscle protein synthesis, the process of building new muscle tissue, particularly in older adults facing anabolic resistance. In one clinical trial, older individuals who supplemented their diets with omega-3 cells gained significantly more muscle strength and size when combined with resistance exercise compared to those who didn't. Salmon also provides high-quality protein, vitamin D, and B vitamins, all of which support muscle metabolism. Just 2 servings a week can deliver these benefits without needing supplementation. Next on the list are eggs, often called nature's perfect protein source. Eggs provide all 9 essential amino acids in optimal ratios for human health, but what sets them apart for muscle preservation is their leucine content. As we discussed earlier, leucine activates the mTOR pathway, the molecular switch for muscle growth. This is crucial because older adults often need a stronger leucine signal to overcome anabolic resistance. Whole eggs, not just egg whites, are especially beneficial because the yolk contains additional nutrients like vitamin D, choline, and healthy fats that work synergistically to support muscle and nerve function. Research comparing whole eggs to egg whites after resistance training found whole eggs stimulated muscle growth more effectively, likely due to these added nutrients. For older adults aiming to protect leg strength, 1 to 2 eggs per day combined with other high-quality proteins can be a game changer. Our third food, Greek yogurt, may surprise some people because dairy has received mixed attention over the years. But high-protein fermented dairy products like Greek yogurt or skyro offer unique advantages. First, they provide both fast-digesting whey and slow-digesting casein proteins, ensuring a steady release of amino acids to muscle tissue over several hours. This helps prevent the muscle breakdown that can occur between meals, especially overnight. Second, fermented dairy delivers probiotics that support gut health, which emerging research links to reduced inflammation and better muscle function. Finally, many Greek yogurts are rich in calcium and vitamin D, nutrients essential not only for bone strength but also for muscle contraction and nerve signaling. Consuming Greek yogurt as a post-exercise snack or evening protein source is a practical way to support both muscle and metabolic health. The fourth food is spinach, representing the broader category of dark leafy greens. Spinach contains nitrates, natural compounds that improve blood flow by enhancing nitric oxide production in the body. Better blood flow means more oxygen and nutrients reach working muscles, improving endurance and recovery. A study in the Journal of Nutrition found that older adults with higher nitrate intake from vegetables like spinach had significantly stronger lower limb muscles and faster walking speeds than those with lower intake. Spinach also delivers magnesium, potassium, and antioxidants like lutein and beta-carotene, which combat the oxidative stress linked to muscle fatigue and aging. Including a cup of cooked spinach or similar greens daily can meaningfully impact muscle performance over time. Our fifth choice, Blueberries highlights the power of polyphenols, plant compounds that activate longevity pathways inside our cells. Blueberries are particularly rich in anthocyanins, which have been shown to reduce exercise-induced muscle damage, improve insulin sensitivity, and stimulate mitochondrial biogenesis, the creation of new mitochondria. Since mitochondrial decline is a major driver of muscle weakness with age, foods that boost mitochondrial health are invaluable. In one study, older adults who consumed blueberries daily experienced improved muscle recovery and reduced oxidative stress after exercise. Adding a handful of blueberries to breakfast or snacks is a simple, evidence-based strategy for supporting both muscle and metabolic health. Finally, we come to lentils, standing in for the broader group of legumes like chickpeas, black beans, and kidney beans. Lentils are a plant-based protein powerhouse, offering not only essential amino acids but also iron, magnesium, potassium, and fiber. The combination of protein and complex carbohydrates in lentils provides steady energy for muscles while supporting insulin sensitivity, a critical factor for nutrient delivery into muscle cells. Their fiber content also nourishes gut bacteria, leading to the production of short-chain fatty acids that reduce inflammation and may indirectly support muscle function. For individuals looking to limit animal protein or diversify their diet, lentils offer a low-cost, highly nutritious option for maintaining leg strength. What unites these 6 foods, salmon, eggs, Greek yogurt, spinach, blueberries, and lentils, is how they address multiple biological pathways involved in muscle health. Salmon and eggs directly stimulate muscle protein synthesis. Greek yogurt sustains amino acid delivery while supporting gut and bone health. Spinach enhances blood flow and muscle efficiency. Blueberries protect mitochondria and reduce inflammation, while lentils provide plant-based protein and metabolic support. Importantly, these foods don't work in isolation. Muscle health thrives on synergy, the combined effect of high-quality protein, anti-inflammatory compounds, vitamins, minerals, and bioactive plant molecules working together. When integrated into a diet emphasizing whole, minimally processed foods, these 6 choices create a nutritional environment where muscle preservation becomes the default rather than the exception. For older adults, the goal isn't just to add years to life, but life to years, maintaining the strength to walk confidently, climb stairs, travel, and stay independent. By prioritizing these 6 foods alongside regular resistance training and overall healthy lifestyle habits, we can slow, stop, and even reverse much of the leg weakness once considered inevitable with age. This is where the science of longevity meets everyday choices, transforming what we eat into a powerful tool for strength, vitality, and independence well into later life. Knowing which foods protect muscle strength is only half the battle. The real challenge and opportunity lies in translating this knowledge into daily habits that fit naturally into our lives. Because when it comes to longevity and muscle preservation, consistency matters more than perfection. The body responds to what we do every single day, not what we occasionally attempt. And the science is clear. The earlier and more regularly we integrate these nutrient-rich foods, the more effectively we can maintain strength, mobility, and independence as we age. The first principle is timing. Muscles respond differently to nutrients depending on when they're delivered. Research shows that spreading high-quality protein evenly across meals is far more effective for stimulating muscle protein synthesis than consuming the majority at dinner alone, a pattern many older adults fall into. For instance, instead of having a light breakfast, a modest lunch, and a protein-heavy dinner, distributing 25-30 grams of protein at each meal maximizes muscle-building signals throughout the day. This is particularly important because older adults experience anabolic resistance, meaning they need a stronger signal to stimulate muscle repair compared to younger individuals. So what might this look like in practice? A breakfast of Greek yogurt topped with blueberries and a sprinkle of chopped nuts provides high-quality protein, polyphenols, probiotics, and healthy fats right at the start of the day. Add a hard-boiled egg or 2 on the side, and you've met your leucine target for muscle protein synthesis before noon. Contrast this with the typical breakfast of toast or sugary cereal, which spikes blood sugar, fuels inflammation, and offers almost no meaningful support for muscle health. Lunch offers another opportunity to integrate these foods strategically. A salad with spinach as the base, tossed with lentils, cherry tomatoes, cucumbers, olive oil, and a serving of grilled salmon, creates a nutrient-dense, muscle-supportive meal. Here we're combining plant-based proteins, omega-3 fatty acids, nitrates for blood flow, and antioxidants for inflammation control, all in one dish. If salmon isn't available, sardines or mackerel can be substituted. Even canned versions retain most of their nutritional power. The key is not rigid perfection, but consistent exposure to these muscle protective nutrients day after day. Dinner can then focus on balance, rather than overloading protein all at once. A vegetable stir-fry with legumes like chickpeas or black beans, served alongside quinoa or brown rice, delivers steady energy, plant proteins, and fiber for gut health. Remember, the gut-muscle connection is real. By feeding beneficial gut microbes with fiber-rich foods, we reduce inflammation and enhance nutrient absorption, both of which protect muscle tissue over time. Another critical point is how these foods interact with exercise. Resistance training remains the single most powerful stimulus for muscle growth, especially in the legs, but nutrition amplifies the signal. Consuming protein-rich foods within a few hours after exercise significantly improves muscle protein synthesis. A simple post-workout option might be Greek yogurt with berries or a lentil salad. Both provide the amino acids and micronutrients muscles need for repair. For those concerned about practicality or cost, it's worth emphasizing that these foods don't need to be expensive or complicated. Eggs remain one of the most affordable, high-quality protein sources available. Lentils and beans cost far less than meat, while providing fiber, iron, and plant-based proteins. Frozen spinach retains nearly all the nutrients of fresh leaves, making it easy to add to omelets, soups, or smoothies. Even frozen blueberries deliver the same polyphenols as fresh ones at a fraction of the cost in many regions. The goal is accessibility and consistency, not perfection or elitism. Hydration also plays a subtle but essential role in incorporating these foods effectively. Muscles are nearly 3/4 water, and dehydration impairs strength, endurance, and recovery. Many older adults live in a constant state of low-level dehydration without realizing it because the sense of thirst declines with age. Pairing protein-rich meals with water or herbal tea rather than sugary drinks supports muscle metabolism without adding inflammatory sugars or empty calories. Snacking offers another chance to sneak in muscle-supportive foods. Instead of chips or sweets, a handful of nuts with blueberries or a small bowl of Greek yogurt delivers protein, healthy fats, and polyphenols. A piece of whole grain toast topped with mashed lentils, olive oil, and spinach makes a savory, nutrient-packed option far superior to ultra-processed alternatives. These small changes, repeated consistently, reshape the nutritional environment in which our muscles age. Meal timing also intersects with longevity science in fascinating ways. Researchers studying time-restricted eating, a form of intermittent fasting, find that compressing food intake into a 10-12-hour window can improve insulin sensitivity, reduce inflammation, and even enhance mitochondrial health. For muscle preservation, this doesn't mean skipping protein or undereating, but rather aligning meals within a consistent window that allows overnight fasting and cellular repair. For example, finishing dinner by 7 p.m. and eating breakfast at 7 a.m. provides a 12-hour fasting period without extreme restriction. When combined with the nutrient-dense foods we've discussed, this approach supports both longevity pathways and muscle health simultaneously. It's also important to consider individual preferences and cultural food traditions. Lentils might be central in one cuisine, while fatty fish dominates another. The science doesn't demand rigid uniformity. It invites adaptation. The core principles, adequate protein, omega-3 SAF, polyphenols, anti-inflammatory compounds, vitamins and minerals, can be met through many food combinations, depending on taste, availability, and personal ethics, including vegetarian or pescatarian preferences. Ultimately, incorporating these foods daily isn't about chasing perfection or building an idealized diet overnight. It's about creating default patterns, habits so automatic they require little thought or willpower. The person who keeps eggs, Greek yogurt, lentils, spinach, salmon, and blueberries as regular staples will, over months and years, build a biological environment where muscle preservation is the norm rather than the exception. And this is the real goal, to make muscle health effortless. Because the science of longevity teaches us that aging is not driven by a single factor, but by the cumulative impact of thousands of small cellular events happening every day. By repeatedly providing the nutrients that muscles need to grow, repair, and resist decline, we shift the balance towards strength, resilience, and independence, not just for the next workout, but for the next decade and beyond. When we talk about maintaining strength and independence well into our 70s, 80s, and even 90s, it's easy to focus on short-term fixes, specific exercises, diets, or supplements promising rapid results. But real longevity isn't built on temporary interventions. It comes from creating long-term systems, habits, environments, and biological conditions that protect muscle function year after year. Our legs, the first to show signs of aging, require a particularly strategic approach because they carry the heaviest burden of daily life. Strength in the lower body isn't just about mobility, it's about preserving autonomy, reducing fall risk, supporting metabolic health, and ultimately extending both lifespan and health span. The first long-term strategy begins with resistance training. Among all interventions studied for aging muscles, none are as consistently effective as strength training. Even modest programs, 2 to 3 sessions per week, have been shown to dramatically slow or even reverse age-related muscle loss, especially in the legs. Exercises like squats, lunges, and step-ups mimic real-life movements, strengthening not just muscles, but also the neural pathways and balance systems that prevent falls. What surprises many people is that research shows benefits at any age. Studies on individuals in their 80s and 90s reveal significant gains in strength and mobility after just a few months of progressive resistance training. It's never too late to start, and the earlier you begin, the greater the long-term payoff. But exercise alone isn't enough. As we explored earlier, anabolic resistance, the reduced ability to build muscle with age, means older adults must pair strength training with optimized nutrition to see maximal benefits. Spreading protein intake evenly across meals, emphasizing leucine-rich foods like eggs and lentils, and including omega-3 cis from salmon or other fatty fish, amplifies the muscle-building response to exercise. This combination of nutrition and resistance training creates a synergy where each intervention strengthens the effect of the other, leading to long-term preservation of muscle mass and power. Another critical factor is inflammation control. Chronic, low-grade inflammation, or inflammaging, silently erodes muscle tissue over decades, disrupting the signals for repair and accelerating breakdown. Diet plays a major role here. Antioxidants from blueberries, spinach, and other colorful plants neutralize free radicals, while polyphenols activate longevity pathways like sirtuins and AMPK, both of which enhance mitochondrial function and cellular resilience. Omega-3 fatty acids reduce pro-inflammatory cytokines, creating an internal environment where muscle preservation becomes easier. Over years, this anti-inflammatory dietary pattern doesn't just protect muscles, it also supports cardiovascular health, brain function, and metabolic stability, all of which indirectly safeguard mobility and independence. Mitochondrial health deserves special attention as a long-term strategy. These tiny power plants inside our cells fuel every step we take. With age, mitochondria decline in both number and efficiency, leading to fatigue, weakness, and slower recovery. But research shows this decline isn't inevitable. Certain nutrients, polyphenols from blueberries, catechins from green tea, resveratrol from grapes, and compounds in dark leafy greens, activate genes involved in mitochondrial biogenesis, the process of creating new mitochondria. Exercise itself, especially high-intensity interval training combined with strength work, also stimulates this process. Over time, this dual approach, nutritional support plus targeted exercise, can rejuvenate mitochondrial networks, improving muscle endurance and strength well into later decades. Hormonal balance forms another piece of the long-term puzzle. Testosterone, growth hormone, and insulin-like growth factor 1, IGF-1, all decline with age, reducing the body's ability to maintain lean mass. While synthetic hormone replacement carries risks and remains controversial, lifestyle interventions offer safer alternatives. Resistance training naturally boosts anabolic hormones while maintaining a healthy weight, and avoiding excessive refined carbohydrates prevents the insulin resistance that accelerates muscle loss. Emerging research also shows that time-restricted eating, limiting food intake to a 10-12-hour window, can improve growth hormone secretion and insulin sensitivity, both of which indirectly support muscle preservation. We also need to address the gut-muscle axis, an area of longevity research gaining enormous. A diverse, fiber-fed gut microbiome produces short-chain fatty acids like butyrate, which lower inflammation and improve metabolic health. Over decades, this translates to better nutrient absorption, reduced muscle breakdown, and improved overall resilience. Legumes, vegetables, fruits, and fermented foods like Greek yogurt or kefir feed beneficial gut bacteria, creating a self-reinforcing cycle where gut health supports muscle health, and vice versa. Then there's the importance of neuromuscular function. Muscle strength isn't just about fibers, it's also about the nerves that control them. With age, motor neurons die off, particularly those linked to fast-twitch fibers responsible for power and balance. Strength training helps preserve these connections, but so do activities challenging coordination and agility, dancing, hiking on uneven terrain, or even simple balance exercises like standing on one leg while brushing your teeth. These small daily habits keep neural circuits active, ensuring muscles respond quickly when needed, reducing fall risk over the long term. Finally, we can't ignore the role of lifestyle integration. Too often, health interventions remain siloed. People exercise without changing their diet, or eat well but stay sedentary. Long-term success requires stacking these habits together so they reinforce each other. A day that begins with a protein-rich breakfast, includes resistance training, features anti-inflammatory foods like salmon and spinach, ends with a 12-hour overnight fast, and incorporates adequate hydration and sleep sends powerful overlapping signals to every system in the body: repair, grow stronger, stay resilient. Sleep in particular is non-negotiable. Growth hormone secretion peaks during deep sleep, driving tissue repair and muscle recovery. Chronic sleep deprivation raises cortisol, the stress hormone that accelerates muscle breakdown and fat gain. Prioritizing 7-9 hours of quality sleep each night may be one of the simplest, most overlooked long-term strategies for preserving strength and independence. When you combine all these elements, resistance training, nutrient timing, anti-inflammatory foods, mitochondrial support, hormonal balance, gut health, neuromuscular training, and lifestyle integration, you create a biological environment where muscle decline slows dramatically. The legs, often the first to weaken with age, can remain strong, stable, and powerful well into later decades. And this is the ultimate goal of longevity science. Not merely to add years to life, but to add life to years, to ensure that in our 70s and 80s, we can still walk with confidence, climb stairs without fear, travel, play with grandchildren, and remain independent. Building this future doesn't require radical interventions, just the consistent application of small, evidence-based habits that compound over time, turning the science of aging into the art of living well.